Right now, 200 million individual stars have just been mapped inside a galaxy that's heading straight for our own, and the picture that data paints is nothing like what anyone expected. This isn't a distant, unfamiliar galaxy billions of light years away. This is Andromeda, our closest large galactic neighbor, the one galaxy in the entire observable universe that's actually getting closer to us instead of racing away. And a brand new analysis of Hubble Space Telescope data just revealed that this massive spiral galaxy is quietly shutting down one of the most important processes happening inside it. Stick around, because the story of what's actually going on inside Andromeda right now is a lot stranger and a lot more relevant to our own galaxy's future than most people realize. And if you want to catch every new discovery about our galactic neighborhood the moment it comes out, go ahead and hit follow before we get into it. Let's start with why Andromeda gets so much attention from astronomers in the first place. Sitting roughly 2.5 million light years away, it's the nearest large spiral galaxy to Earth. Similar in overall structure to our own Milky Way, but roughly twice as massive. On a clear, dark night, away from city lights, you can actually spot it with the naked eye, a faint smudge of light in the constellation Andromeda that represents an entire galaxy containing hundreds of billions of stars. Because it's so close by cosmic standards, and because we can see it at a favorable angle rather than edge-on, Andromeda has become one of the single best laboratories astronomers have for studying how large spiral galaxies actually form, grow, and change over time. Anything we learn about Andromeda's history gives scientists a uniquely detailed comparison point for understanding our own galaxy's past and future, since the two are similar enough in structure that lessons learned from one often apply surprisingly well to the other. For decades, one particularly strange fact about Andromeda has stuck out to astronomers. Nearly every other major galaxy in the observable universe is moving away from us, carried outward by the overall expansion of the universe itself. Andromeda is the one glaring exception. Instead of drifting apart from the Milky Way the way galaxies typically do, Andromeda is actually falling toward us, pulled in by mutual gravity between the two galaxies, on a slow collision course that scientists estimate could eventually bring the two galaxies together several billion years from now, though the exact outcome and timing of that eventual merger remains an active area of research and some uncertainty. That single unusual fact alone has made Andromeda one of the most closely studied objects in the night sky, because understanding exactly how it's changing right now gives astronomers a preview of dynamics that could eventually play out much closer to home. Now, a newly published study is adding an entirely new layer to that story. Researchers combined two major Hubble Space Telescope surveys, together covering roughly 2/3 of Andromeda's visible disk, resolving and analyzing approximately 200 million individual stars scattered across the galaxy. That's an almost unimaginable number of individual data points, each one a real, physical star whose brightness, color, and characteristics scientists carefully measured and cataloged. Piecing together information from that many stars at once let the research team do something that's normally extremely difficult, reconstructing a detailed timeline of exactly how and where, and how quickly Andromeda has been forming new stars over the past several hundred million years. What they found was a clear, steady decline. According to the study, Andromeda was forming new stars at a rate of roughly one solar mass worth of material per year around 500 million years ago, a healthy, active pace for a galaxy of its size. By around 40 million years ago, that rate had already dropped by half. And today, current measurements put Andromeda's star formation rate at only about 1/5 of a solar mass per year, a dramatic decline from where it stood just a few hundred million years earlier. In other words, whatever process was fueling new star formation across large portions of the galaxy has been steadily losing momentum, and Andromeda now appears to be settling into a noticeably quieter phase of its life than it experienced in the relatively recent cosmic past. To understand why this matters, it helps to know a bit about Andromeda's more distant history. Roughly 2 billion years ago, scientists believe Andromeda experienced a dramatic burst of star formation, likely triggered by a merger or extremely close interaction with another galaxy, probably a smaller companion galaxy known as M32, which still orbits Andromeda to this day. That ancient burst was so intense that it's thought to have produced roughly 1/5 of every star currently existing anywhere in the entire galaxy, an enormous contribution packed into a comparatively short window of cosmic time. Mergers and close galactic encounters like that tend to compress and stir up huge amounts of gas, creating exactly the kind of dense, turbulent conditions new stars need in order to form in large numbers. What this new Hubble study suggests is that Andromeda has essentially been coasting on the after effects of that ancient collision ever since. And only now, billions of years later, is that burst of activity finally winding all the way down. One of the most interesting details buried in the new research involves exactly where inside Andromeda this slowdown is happening. Researchers found that most of the galaxy's remaining star formation is concentrated within a specific ring-shaped region located roughly 32,000 light-years from Andromeda's center, and it's the declining activity specifically within that ring that's driving the overall galaxy-wide slowdown. That's a genuinely useful clue because it tells scientists this isn't some uniform galaxy-wide event happening everywhere at once. It's concentrated in a particular structural feature, suggesting the physical mechanism behind the decline is tied to something specific happening within that ring. Whether that's a gradual depletion of available gas, changing dynamics within the disk, or some other structural factor, scientists are still working to pin down. Researchers also specifically investigated whether Andromeda's small companion galaxy, M32, might be playing a role in accelerating this slowdown in certain regions. Interestingly, the regions of Andromeda, located closest to M32, do show a somewhat more recent decline in star formation compared to areas farther away, hinting that the ongoing gravitational relationship between the two galaxies could be influencing exactly how and where this cooling off process unfolds. That said, the researchers themselves have been careful to note that this particular piece of evidence remains inconclusive, and it will likely take additional observations and further analysis before scientists can say with real confidence whether M32 is actively shaping the pattern or whether the correlation is simply coincidental. One of the study's co-authors, astronomer Ben Williams from the University of Washington, explained why this kind of star-by-star analysis matters so much for understanding a galaxy's history. Individual stars essentially function as a fossil record, preserving detailed information about the conditions under which they formed, long after the original burst of activity that created them has faded away. Reconstructing that fossil record requires being able to resolve enormous numbers of individual stars with extremely high precision across a large area of sky, which is exactly the kind of observation that requires a space telescope with Hubble's specific combination of sharp resolution and wide field of view. According to Williams, no other current telescope offers quite that same combination of capabilities when it comes to studying a galaxy the size and distance of Andromeda in this kind of detail. What makes this discovery particularly compelling isn't just what it tells us about Andromeda specifically. It's what it suggests about how large spiral galaxies evolve more generally. If a massive, otherwise healthy-looking spiral galaxy like Andromeda can experience a dramatic multi-billion-year burst of star formation following a major merger, and then gradually wind back down toward a much quieter, slower rate of activity over subsequent billions of years, that pattern likely applies to plenty of other large spiral galaxies, scattered throughout the universe, including, potentially, our own Milky Way at various points in its own history. Galaxies aren't static objects. They go through active phases and quiet phases, shaped by collisions, mergers, and the slow depletion of available star-forming gas. And Andromeda's newly reconstructed timeline offers one of the clearest, most detailed real-world examples of exactly what that kind of long-term cooling process actually looks like, when you can measure it star by star rather than relying purely on theoretical models. This research also arrives at a particularly interesting moment for the study of Andromeda specifically. NASA's Nancy Grace Roman Space Telescope is preparing to launch on a SpaceX Falcon Heavy rocket as soon as the end of August 2026, and one of the mission's researchers are already planning for the new observatory. It involves turning its attention toward Andromeda. Roman's field of view is expected to be at least 100 times larger than Hubble's, meaning that where Hubble needed multiple separate surveys just to cover roughly 2/3 of Andromeda's disk, Roman should eventually be capable of surveying the entire galaxy, along with its surrounding halo of more distant, scattered stars, in a single coordinated campaign. That kind of complete, wide-field coverage could dramatically sharpen scientists' understanding of exactly how Andromeda's star formation has varied across its full structure, potentially resolving some of the open questions this current study wasn't quite able to answer, including exactly how much of a role M32 has actually played in shaping the pattern researchers are now seeing. For now, though, this new Hubble-based reconstruction stands as one of the most detailed timelines ever assembled for how a major spiral galaxy's star-forming activity rises, peaks, and gradually fades over the course of billions of years. Andromeda isn't suddenly running out of material or facing some kind of abrupt shutdown. It's doing something much slower and, in its own way, much more elegant, gently settling down from an ancient burst of activity, one region at a time, as the effects of a collision that happened long before humans existed slowly work their way out of the galaxy system. And there's something worth sitting with in the fact that all of this is happening in a galaxy that continues drifting closer to our own with every passing millennium. Andromeda's gradual decline in star formation is unfolding on a timescale of hundreds of millions of years, the same broad stretch of cosmic time over which its slow gravitational dance with the Milky Way continues to play out. Studying exactly how a massive galaxy like this settles into a quieter phase after a major merger gives scientists a genuinely valuable preview of the kinds of processes that could eventually shape our own galaxy's future whenever that long-anticipated meeting between Andromeda and the Milky Way finally arrives. If a story like this, watching an entire neighboring galaxy wind down star by star while it slowly falls toward our own, is the kind of thing that genuinely fascinates you, go ahead and subscribe. Drop a comment letting me know what you think Andromeda's next few billion years will look like, and stick around, because there's a lot more coming out of Hubble, and soon out of Roman as well.